In this lecture, I will discuss robust regression. Please refer to my earlier videos on running regression and diagnostics tests before watching this video. It's rare to get a data set that satisfies all the assumptions of OLS regression. Robust regression is an alternative to OLS when the data set suffers from the problems of influential observations. If we find outliers or high leverage points in the estimate of OLS, we may decide not to ignore this data since there is no error in recording data. Robust regression may be used since it does not entirely exclude these data points. Robust regression weighs each observation differently based on its behavior. It's a method of weighting and reweighting OLS. We must notice that robust regression does not solve the problem of heterogeneity. In that situation, we can use robust command with regression command in stata. Before using robust regression, you should first run regression command in stata, followed by post-estimation diagnostics for regression. Once you detect the problem of influential variables, you may use robust regression. Now here is our data. Now the variables are these. Variables include murder as dependent variable or outcome variable as we call it. The independent or explanatory or response variables are violent, urban, white, high school, poverty. Violent and murder are in numbers, while other variables, that is urban, white, high school, poverty, they are percentages. Now let's run our OLS regression. Murder is dependent, violent, urban, white, high school population, poverty. This is our output. Let us look at the output. Now we find that violent is highly significant and this is the coefficient. Urban is not significant, it has no impact. White is significant at 10% only, it has negative sign. High school is quite significant at 1% and its coefficient is 0.54. Similarly, poverty is very significant. So we find that except urban and to some extent white, other three variables are significant. Now in earlier videos, I have shown that our data set suffers from the problem of heterogeneity, non-normality, influence variables, etc. If data has problem of heterogeneity, we can use robust or cluster command with regression command. Let's do that. Now this time we use our command regression, but after comma we add robust. This will give us robust standard errors. Now here these standards are errors in the earlier model. These are not robust. Now heterogeneity would affect your standard errors. It does not affect your coefficients. Now let's look at our results and we find that the robust standard errors are different from these ones. Now, for example, we find that it has slightly decreased in case of urban, it has increased in case of violent, and in case of white, there is difference again. So you find that there is difference. Of course, in case of poverty, from 0.21, it has gone up to 0.28. So what we see here that coefficients are same, but the standard error is different. Now, let's run robust regression. So for that, once again, the only thing here is that you write RREG for the command. And when I enter, I get this output. Now what do I find here? That violent has become significant at 10%. Earlier it was significant at 1%. Similarly, urban remains insignificant in all three models. White, now we find that in case of white, the coefficient has changed significantly. It has become almost a double, and it has also become very significant. In the case of this command, when we use the command robust, white became insignificant. High school, which was significant here, has become insignificant after we run a robust regression. Similarly, in case of poverty, which was significant at 1%, is now significant at 5%. Therefore, we find that there is difference in coefficients as well as standard errors when we run robust regression. Now, you may notice that this estimate is not giving you R square or adjusted R square. Now, there is a command for that. Of course, you will have to install it if you don't have it. So you will do ssc install. The command is rreg fit. Well, I have this command already. So in your case, you will go for this command, and then when you click it, you shall get additional information about this regression. Now, R square is 0.61. AICR is 69, BICR is 81.6, and deviance is 65.